how to make Among Us in Unity. If you haven't seen the previous episodes, I recommend you check them out because they are needed to complete each step. I provided a nice playlist for that should appear right now. Welcome to the place where game dev starts. My name is Adrian and I'll be your host. If you're struggling with the tutorials or just simply want a shortcut because you don't have enough time, I've created a nice asset with all the tutorials combined plus something extra. By the way, the latest update introduced password protected and secret rooms, which are only for the people that are buying the package. So if you're interested in that, check the link in the description for more details. By the way, join the Redefiners gang on Discord. There we are talking about a lot of game development. Now let's get straight to the main topic for today. In this video we'll discuss about two mini games from Among Us, more specifically Unlock Manifolds and the other one Start Reactor. Let's begin with unlocking those manifolds. This puzzle is very simple. A player needs to correctly trigger a sequence by hitting the numbered buttons. For this tutorial episode, I've chosen to go through the full process without any speedups. If you're interested in particular places, I've provided video chapters that will allow you to quickly navigate through the video. And I'll start with the UI. Usually, here we can begin with an UI image. Why is an image and not an empty game object? Well, it's because it's easier to see it around when positioning in the screen. We can toggle the image component on or off as we like. Next, we will create an internal background for the task holder. The most common element of this task is the button. We will group them into two rows, each one containing a horizontal layout group component. Feel free to experiment with different spacing or padding settings. As you can see, I'm also experimenting as well while creating some placeholders around. I'm making a lot of use of images for positioning and after removing them when not necessary anymore. This is a good way to visualize the context better. After I'm happy with the results, I will clear everything and just use a single button as a final prototype to create everything out of it. It's not needed to assign numbers here because they will be assigned in the code, but it looks nicer. Let's create the unlock manifolds task script. In here, we will keep a list of all the buttons in the task. We will also have a callback for when a button is pressed to process it. In awake, happening only once when the object gets created, we will do a couple of different things, but all to one goal: to assign unique numbers randomly to the buttons. For this, I like creating the list with all the numbers available. Then, for each button, first we will randomize and get the number. We will assign that number to the button. Currently, I am commenting here because we don't have the button functionality yet. And lastly, after the number was picked, we need to remove it from the list to prevent duplicate button numbers. Let's create the button script now. In the button script, we will keep a reference to the button's text as well as the button UI component. In initialize, we will set the button's value to the provided one. If there is no reference to the button text, for example when the script is run for the first time, we need to get the required components. We will also initialize the button's text with the provided value. Lastly, we will rig the buttons on click event so that we can get notified when the player clicked it. In this function, we need to call back to the main task. To make this work, we need a reference to the parent task. Don't worry if the parent task doesn't have the function yet, we will get there soon. For consistency reasons, I've opted to rename the button press function. Make sure when developing to keep the names consistent across multiple scripts. Back to the task, now we can properly initialize the button. Don't forget to change the button's list type, otherwise you won't have the initialize function to call it from the button. Let's set up a small debug and see if the buttons work properly. Now let's assign the scripts to their corresponding objects. And here, as you can see, I made my first mistake, trying to fit the button objects that don't have the button script attached yet. Remember, first you need to assign the button script, and after you can initialize the task with the buttons. Now we can finally test, and they are getting assigned random numbers. That's good. To eliminate the number 0 from the buttons, we need to increment with 1 because the indexing starts at 0. Testing again shows that button pressing works as well. Now, in the button script, we will implement the disable functionality. In the main task file, we need to store the current step we are at in the current sequence. Let's quickly move everything from awake to on-enabled. This will allow the task to randomize every time this game object gets enabled. The awake function only initializes once the application starts. In the button pressed, we need to check the button's value against the current value. If they're the same, the correct button was pressed and we can continue. If not, the player made an error and the task finished with fail. We can also implement the reset functionality to clear the buttons from being disabled. Now we just need to test the end condition to disable the task. And this is the final result. After finishing these tasks, as with previous tasks, we'll make a prefab out of it by dragging and dropping it in the project window. Now let's move on to the Start Reactor task. This one is a little more difficult. It's based on a game called Simon Says. Basically, there are a couple of steps, and after each one the player needs to repeat the presented pattern. The pattern gains more and more steps with each successful sequence from the player. To explain the main idea, we will generate random sequence. This is the final one, for example, 5, 3, 1, 2, 4. The player does not start with this one, just a subset. In this case, it would start with step 1, which is 5. Then step 2, which is 5, 3, and so on and so forth. To keep track only of the sequence location is not enough. We need to keep track of what is inside the sequence. For this, we will use steps. Each step is basically a sequence that has one more number. If we create an index and point to the step's current position, we can track how the player is dealing with the task. How can we do this? Well, we start with the UI. It's divided into two main parts, left and right. In the left one, we will count the successful steps and also display the pattern to follow. In the right one, we will display the buttons the player needs to press in order to input the correct pattern. Let's begin with the Reactor button script. Here we need to hold the button's index and the Reactor task. You will use a similar initialization as in the previous task and, of course, hook up the button to the click event. Going to the main Reactor task, here is where we have more steps. First, we will define the active color for the images that display the pattern. Also, it would be nice if you can specify the time for how long the images should be displayed. For the lists, we will keep the buttons from the right, the images that form the pattern, and the images at the top which show the current progress through the task. The progress is held in the current sequence index. In current step is the current step in the given sequence. We will directly implement the sequence generation functionality in onEnable. One thing to note here is that we will prevent the sequence to be generated every time this task is started to be true to the original game. The generation of the sequence is very similar to the previous task. The main difference is that instead of taking random indexes, we are using the images index. The unique image index list is used to make sure that you don't pick the same image twice. Also, it's good to clean up the buttons before we start a new task run. For the reset, we will also add the image cleanup. To show the sequence to the player, we will use a function called playSequence. It will be a coroutine because it needs to wait a couple of seconds between each highlighted image. In the sequence, first we will disable all the buttons. Next, from 0 to how many steps are displayed, we will display each one of them with the delay to make sure that the player sees them. After the sequence animation is completed, we can re-enable the buttons. Of course, similar to the play sequence, we will have a coroutine show error. Here we will flash all the images with a color, let's say red, to display that the player made an error. After the error is played, we will replay the correct sequence for the player to start again. Similar to the previous task, we will use the same button callback, which gets called in each button. The main take from here is that we will check if the step is the correct one. And if it is, we can advance the step number. If we finish the steps in that sequence, we can move to the next sequence. After each sequence change, we need to display the new animation for the player. Lastly, we need to check the ending condition. That means if the player finished all the sequences. Now it's time to assign the components in the inspector and we can test. And this is it for today. If you enjoyed this episode, don't forget to leave a like and subscribe to the channel, because more videos are coming very soon. See you in the next one. My name is Adrian and I'm signing out.